All right, so the intended vibe of this is, how does GPT-J do arithmetic? Where there was this why did I square bracket in? So there was this recent paper, and the paper found that you could look at how GPT-J did arithmetic. It was actually fairly competent at doing things like addition, subtraction, multiplication, and division. And they found this like kind of wild result that MLP20 just seemed incredibly important for everything, and otherwise it did not seem important. But unfortunately, the paper used this kind of weird metric called the indirect effect. I don't quite understand what this metric shows or like why they chose it, but this means that their results look like really, really sharp and extremized, when in practice the effect of MLPs seems more diffuse, which is sad. But this is still interesting because addition is like a task I'm pretty excited to better understand. This paper has convinced me that GPT-J is actually good at it, and there's some amount of like actual structure and sparsity here. And I want to go understand it. And I very, very briefly poked around at this before, where my main findings were, if you use a smoother metric like logprob, this graph looks much smoother. And if you, and also GPT-J can indeed do arithmetic. It's great. And I can't remember where I put my code for that, so I'll just YOLO rewrite things. And also make myself a new GitHub repo for this. And yeah, so I intend to work on this for about 2.5, 3 hours, which is not that long. And plausibly, I will not actually prioritize working on this beyond that because I have way too many in-progress research things. And so I want to begin by just thinking through, like, what is an interesting thing I might actually be able to speedrun? And I will call this file scratch.py because I'm incredibly imaginative. And yeah, we're in setup, we're in setup. This is my beautiful cursed file with every import I care about having. It's majestic. I highly recommend this Galaxy Brain workflow that is definitely principled and would obviously pass DeepMind code review. It's a lazy researcher's friend. Anyway, words, things. And I will store my thing in bfloat16 because I don't want to have to worry about and I want everything to run fast, even though bfloat16 will sometimes fuck with my results, but YOLO. Though I'm also renting an 80 gig A100, which will hopefully make me not constantly suffer because that is what you want. Anyway, so I'm just gonna leave this thing running because it might take a few minutes to download GPT-J because GPT-J is big. But yeah, so intended spirit of this is something like, Yeah. What is something interesting that I could actually get out in like a hacky couple of hours? This is not an obvious question to me. And yeah. So what am I actually curious about when it comes to, sorry, just pinging Slack. Yeah. So what am I actually curious about with addition? I'm curious if people have things they're curious about and how language models do addition. Questions to the group before I stop rambling. All right, I'll assume no one is curious about anything and think this is boring and mundane. Loves?
First thing that comes to mind is how does it deal with like the same number tokenized in different ways? Because that just seems very weird.
Yes. I'm going to label that as out of scope. Because a fun fact about the GPT-J tokenizer is if you don't have spaces, all numbers between 0 and 510-ish are single tokens, which means I don't need to care about that question. Though, I don't know. My guess is that there's going to be some kind of representation in the embeddings of like numberiness, and that any of the models is going to have some like detokenization. Hey, Adam. Any of the models are going to have some amount of like detokenization for longer numbers that like convert this to the representation. The thing which is fucked is that models are capable of doing this with like inconsistent place value, where like some number gets 3 tokens, which means you can have like 3-digit. You can do like 3-digit equivalent, and then some number will get 1 token. And the model needs to figure that out. And like, I have no clue how that works. But I intend to restrict myself to 1 token addition. As context for Adam, my quest is understand how GPT-J can do addition of numbers between 0 and 500. And question to the group is, what are people curious about with the generic observation that models can do this? Nikhil?
Yeah, the one thing I was just curious about, or just thinking about, was how does the embedding of this tokens, this number tokens related? Like, is the token 500 more related to token 501 than then it is related to 100 token 100?
This is a great question. So, all right. First thing that I want to look at is the singular value. Let's make a list of things I care about.
And one more thing, probably, could you just increase the size? I mean, I don't know if it's problem for other, but could you just increase the size of your, yeah, that would be good. Yeah.
Good point. Thanks. That's 2 themed in. Is that okay with people?
Yeah, that's okay. At least for me.
All right. So yeah, actually, I can make my notes window much smaller, and then make this a little bit larger. But yeah. All right. So what is the structure of the embeddings? Where YOLO do SVD is always the best strategy. The vibe I have from some initial poking around is that models are like words. My vibe from initial poking around is that models have some like Fourierness in the number embeddings, but they also have magic special things for things that are like multiples of 5 and multiples of 10 and multiples of 100. Because models, man. But yes. All right. What? there is this really obnoxious thing where the but there's this really stupid thing where on this device, there's this really stupid thing where Hugging Face has this cache, and on my cloud provider, you get like a really tiny folder, and for the root, and then there's this large mounted drive, but it does not realize this large mounted drive is like the thing to write to, and it's so annoying. So let's, rerun, set the environment variable, and then see if it successfully caches it in the right place. Oh my God, it caches it in the right place. Life is good. Let us resume the 4-minute download. Hey, let's go. Currently structuring research question of what can we learn about how GPT-J does addition in a few hours. And cool. The prompt to the group was, what are people curious about or confused about here? All right, any follow-ups, what people are confused or curious about?
I don't really know anything about this, but my immediate thought is like, it surely can't memorize 3-digit numbers addition. So somehow it's doing something that simulates it. Is it like, I don't know, choosing a base or choosing a modulo to do it with something periodic?
Then how I think about it, 3-digit addition, it's what, like 1 million facts? Maybe GPT-J can just memorize 1 million facts. I don't know, man. It's got 7 billion parameters. It's like a fact per parameter. It's nothing. Admittedly, I have like no intuition for how much these models can memorize. And they're probably memorizing with extensive superposition and everything's cursed. But it would be hilarious if this project just completely flops because of that. That would be so annoying. Anyway, so, all right. So the thing which I'm personally most invested in is, can I find any hints of the modular addition algorithm via Fourier transforms used here? Because while this is not actually modular addition, this is still like a thing that feels like it should benefit from periodic fuckery, which really is the true spirit of modular addition, something.
Isn't there, I was thinking about this, isn't there kind of a sense it's still like the algorithm that we learned in school where you put the two numbers on top of each other and then carry the 10th digit, and that, like, there's still a modular aspect to that because you're in base 10. So you could imagine that that's the reason why it would benefit from it.
Broadly agreed. The thing which is cursed is that it doesn't get a token per digit. It gets like a token per something. I don't know. A cute thing to print is just, what does the tokenization look like? Or what even is that?
This is probably quite obvious, but why can't the transformer just do normal addition like a normal feed-forward network would be able to when you just train it on addition tasks?
What do you mean by normal addition?
Just add the two numbers together.
How?
Good
I think
question.
the issue is that
Wait a minute.
you know, it doesn't.
Copilot can do correct addition? What the fuck? What happened? This is insanity. Anyway.
I mean, I think the reason why I can't do like naive addition is because it's not getting integers into the network, right? You're putting you're discretizing. All the tokens are discrete symbols, and then you embed them. So like, unless the embedding is doing the work, converting it to an actual numerical value that corresponds to the actual numerical value of the symbol, the way that we understand it semantically when we do addition, then it can't just do that for free, like you would naively do in a feed-forward model.
Yep, pretty much exactly.
Yeah, I guess my question assumes that part of just doing addition is to convert the number in some sort of integer representation.
Yeah, so one intuition for why I don't predict the model to doing something like map it to a vector and then like add the vector is that models, so first off, the way you converting things in to like linear directions is very easy, but converting them out from a linear direction to like a thing where you can do binary classification on each of the numbers is like actually pretty hard. Because you'd need, I don't know, the main way I can think of doing it is you like have a bunch of neurons, which are like, is this thing above 17? Is this thing below 18? Add them together. That's the 17 thing, which is like, fine, but it's kind of inefficient. The other thing which is weird is I think models just don't seem to do great at having a feature they need to precisely track that can take on like a really wide range. Though this is very much a fuzzy intuition. It could very well be the case that just YOLO, this is just how it works. Anyway, so probably first I should set up some utils to figure out what on earth is going on here, or like to have some like basic tooling. So I guess first I want to just num tokens per digit. I just want to figure out for each of the first 1,000 digits what it looks like. And yeah, maybe define some like, it seems good to have some kind of format for this. What? Is this valid code? It would be hilarious if this is just valid code. Huh. It's not doing addition, but it's surprisingly legit. Fucking Copilot, man. Anyway. All right. So my high-level question, can we get any insight into how the model does addition? In particular, how does the model, what's the question I care about answering? In particular, how does the model know? in particular, does the model use something Fourier-ish / periodic-ish? And in terms of how I could imagine actually approaching this, the like dumb, obvious things to try. Understand, well, so there's gonna be like basic setup stuff. Can the model do arithmetic? What is the right prompt format? What is the right domain range to study? And like how cursed is tokenization? I did some like preliminary investigation a few days ago and got concluded that something like things between 0 and 500 are single tokens. So you can do like, I don't know, adding numbers between 100 and 200 to get answers between 200 and 400 as like a kind of coherent thing. And two-shot prompts seems like the right format. So I'm just going to YOLO and say that is a sensible format. And, but yeah, checking can the model actually do arithmetic seems like a pretty crucial thing. Then in terms of actually getting information, the like first obvious thing I want to understand is like how information flows through the model. In particular, where in the model does the addition happen? Where like the obvious places it could happen are like on the 276 token or on the equal sign, and understanding like how that happens seemed pretty interesting. Or like not interesting. It's like, well, if you don't understand that, you're completely doomed. Oh my god, it finished loading. This is incredible. One of the really annoying things about not having persistent storage is if you want to use a large model, you just gotta wait 7 minutes. It's outrageous. Cool. All right. I hate numbers. Is observation 1. And, yep. Tokenization is cursed. And the model is capable of addition. Woo! It correctly knew that this resulted in 494. I'm quite impressed. This is 68%. It's like great.
I like that the number 2 result is off by like 1 digit. Like it forgot to carry the 1.
Oh, that's a good point. And there's lots of things ending in 1-4 as well, which is kind of interesting. Like, why does that happen? I can't see an obvious reason why that happens. Models, man. All right. One thing that's always cute to try is looking at the SVD of the embeddings of the numbers. All right, so this is a line plot of the number of tokens per digit with no spaces. We see that everything before 521 is chill. So just say single token numbers is short A range 520. I'm just doing boring boilerplate right now. Great. Such a cute graph. This is token index. That's right, number against token index. And it's like, well, the model kind of wants shorter things first. It wants 2-digit things much faster. And then it wants like these things, like 360 and 256. These are reasonable things to prioritize about random other crap. But it's otherwise just kind of steadily getting stuff. And it's very cute. I love it. Ooh. IS 431. So rare. Tokenizers, man. And all right. I now want to take I now want to go and look at the SVD of the why has no one implemented SVD for B16? This is outrageous. All right. This looks dumb because presumably there's like a really big mean that is just I'm a number. And I don't care about the I'm a number embedding. So all right. Much more reasonable. Huh. Okay. So I'm surprised by how flat the singular value decomposition graph is. I was kind of expecting there to be like a couple of really important directions that were like all of the periodic information for the numbers. And then, which would mean it looks like really, really sparse. But instead, it's like a very gradual decline. And I had also wondered whether we would get something interesting for what the singular values actually look like. Sorry, what the singular vectors look like. And sorry, how clear is it to people what these graphs represent? Cool. All right. Yeah, this one is like, it's kind of a size direction, but it's a bit weird. And it's totally correlated with some I'm a 2-digit number direction. This one is like periodic-ish, actually. Apart from this crap. All right, new plan. I'm going to look from 100 upwards. It's like pretty damn periodic. Seems legit. And that's like a period of like about 100. Huh. That's surprising. Anyone want to guess what the spikes are?
So I don't know much about GPT-J. The embeddings, are they learned?
Yeah, sorry. So these are the token embeddings, which are always learned. These are not positional embeddings. which in GPT-J are rotary, which is cursed. Yeah, all models learn these. And so this is just like, what is the structure that is beneficial? And I don't know. The more I think about models, the more I'm like, if you have a really good embedding space, maybe everything is just kind of trivial. And maybe most of the point of a model is it just learns a fabulous embedding space. Like, I don't know, in the modular addition case, realizing that your embeddings should be trig terms basically makes the problem trivial.
Yeah, I guess the issue in more general cases is that like you have to do a lot of different things with numbers, not just add them modular 113.
Yep. Yep.
Is it 10? The periodicity here?
You can't specify, if you specify a posting here, it's not fixed out.
Yep.
Yeah.
The spikes are all multiples of 10.
Yeah.
Oh, what? What? These are multiples of 10 plus 1? What the fuck? What? All right. This sure seems periodic. I kind of want to do some more processing. Well, for example, I feel like multiples of 10. So one thing I'm kind of curious about is, so this thing is like length. How long is this thing? So this thing is like length 420. And I'm kind of curious what things look like if we take the average across, if we just average everything which ends in the same digit, which I think the code I've written will let me do. Oh. Ah. Okay, this is less periodic than I'd hoped for. Oh, no, it's pretty periodic. Oh, it's kind of a parity function. These are pretty legit. So I think what I want to do is get the Fourier basis of length n. So these are like terms of different frequencies of length n. Sorry, these are like I want to get the set of waves of period dividing n for different values of n, and like try to connect them up and see what happens, if this makes sense to people. Cool. All right, so let's see if my muscle memory from my grokking work will pull through. You do not need to be following the random trap I'm writing right now. Why is this? Oh, lol. Beautiful. I've successfully made an orthogonal matrix. Life is good. So all right, the thing that I want to test here is if I take the singular vectors and do a Fourier transform on them, do they look like anything interesting? And I get this weird ass result where this is very weird. So the hypothesis that I wanted to test was like, when I took these things, they looked kind of periodic-ish, but we're mod 10s, so periodic things are pretty discrete. So what happens if I like multiply, if I do a Fourier transform, and I can never quite remember which way round I do the Fourier transform. But this has got me this incredibly sparse thing. And apparently this is because the final singular value is constant. But one thing which is striking is I see things like, oh, the frequency, the sine term, which is like alternating, really strongly occurs in like these few singular vectors. I should apply labels. All right, this is probably more comprehensible. So
Why are you averaging over the digits?
so not necessarily in a super principled way, but like when I was looking at this stuff, it was like, oh, some of these seem like really periodic by digits. I wonder if there's some like digit-wise term. Let's go and try to figure that out. And I don't know, it sure seems like there's some structure here. Like the cos1 term, which is like long frequency. I guess I can plot these. Yeah, the cos1 term, which is this like long sweeping one, shows up strongly in like the 0th and the 3rd singular vector. That seems true enough. But it's also not like super clean. Ooh, that's fun. Do I believe that? Huh. Yeah, I believe those are two very similar vectors. That's cute. All right, from this, I'm going to conclude it's actually kind of periodic-ish. I'm taking this as a win. All right, so now I want to go and see if the number embeddings look at all periodic-ish. And I can kind of just repeat exactly the same analysis, I guess. Where, let's do first 10. I can, yeah. So I guess there's like two questions here. One question is like, what even is the right Fourier like frequency to do this over? And this is highly unclear. So I'm just going to YOLO and do it on the range that I have, which as it happens is 420 Blazer. So whatever. And yeah. So and then I guess a separate thing that would be kind of coherent is to take the top 100 Ooh. That's sparse. That's insanely sparse. So interpretation of this graph for people who somehow cannot follow me writing random garbage code. I've taken the embeddings of the numbers between 100 and 520 as just like single token numbers. I've looked at the embeddings of them. I've taken the ones from 100 to 520. I've then taken all of the Fourier terms of frequencies. And sorry, let me just make this graph a bit nicer. Yeah, so what this graph shows is like you take, yeah, so you have each of the top 10 singular vectors of the embeddings of numbers from 100 to 520. I'm looking at the singular vectors over the 100 to 520 side. And when I originally plot them, they have some kind of coherent meaning in the like basis of numbers. So like, here is what it looks like when the x-axis is just the numbers from 100 to 520. And I can apply a Fourier transform to it. So I look at it as a sum of like terms of different frequencies, where each of the terms looks like, I don't know, what are the first 5 terms? Yeah, they look like this. And when I did that, I got this insanely sparse looking thing. And so what I'm getting from this is that if I look at terms like the first vector, it's mostly some like super low frequency stuff plus some super high frequency stuff. And this is, well, it's surprising that it looks sparse in this, because an arbitrary vector should not look sparse in this. The fact that it's only extreme ones is like less interesting, because that mostly just tells me it's kind of smooth. Though I am surprised that it has so I'm surprised that the 0th one has a strong thing for like sine 209. And trying to look at what's going on, sine 209 is just like very, very rapidly bouncing back and forth. And so I guess there's just something about this thing that's like detecting parity a bunch and bouncing rapidly back and forth, which maybe makes sense. This is similar, but it's like shifted somewhat along, which is interesting. And yeah, when I look at what that one looks like, it's like, okay, that has periods about every 100. This makes sense. And yeah. Yeah, it really likes things of frequency 4, which I'm guessing, because I'm doing mod 420, is like about things of frequency 100. And it also quite likes things around 42, 84, 126, which are going to be around things of frequency 420 divided by 42, so like about 10. Which is all suggesting to me there's like something interesting and periodic-ish and base 10-ish around all of this. And this one really, really likes those terms.
Sorry, there's no reason to think that this would care about base 10, is there? Because the embeddings are just different tokens.
Yes,
Right.
This is very much a, oh wow, this has learned some like real structure. Like the reason you should care about base 10 is that like that's just how that's how numbers in language work. But it suggests the model has like learned this in like a genuinely non-trivial way. If that makes sense.
Well, like, is it gonna? Are there more examples in the training data of like 20 plus 20 than 19 plus 19 or something? What?
So what we're seeing now isn't necessarily telling us about like frequency. So what this is telling me is that the model wants to know where things are base 10 in order to like do further computation with them in order to figure out the next token. Which makes total sense, right? Like
Somehow there's like some leakage from the context in the sentence that it can figure out that the people writing the sentence are using base 10.
well, it's just like it's memorized that base 10 is the right base, because you know, outside of Cambridge example sheets, everyone uses base 10 for everything, right? But it sure is weird.
I guess you could ask like a stupid theoretical question, which would be like, if you took the same training data and you just trained a zero layer transformer, just like the embedding and unembedding, if you would get something similar or not.
Yep. That does sure seem to be a thing. That sure does seem to be the kind of question people care about. Admittedly, it's like, I don't know. I would guess a lot of the periodic structure is much more useful if you're trying to do things like addition. But I have seen stuff like this on GPT-2. Anyway, I'm mostly going to label where I am now as like, yep, I feel satisfied that the model is like learning genuinely periodic things in non-trivial ways, and that I should now move on with my life. Though this thing where things are just like one step along is so fascinating. Like what? Why does 30 matter? All right, so one thing which I do want to do is just like look at norms. So let's redo this for numbers between 100 and 500. I now just want to see like how prominent is each Fourier term. And we see, okay, the terms for like 10, 25 are like unusually big. So this is like, well, the model cares about where things are in a way that's like periodic for 10, periodic for 20, periodic for 25, etc. And this is interesting. And we get a similar thing here. Huh. So it seems like it really likes things that are integer multiples. Like, it likes things that are 80 out of 400. So things with like 5 periods. And it likes things that are like 133, which is like 3 periods. I don't actually have a clear mental picture of like the wavy maths here. Anyway, I'm getting caught in a massive tangent, but this was fun. Any questions or confusions that feel actually worth going into all that stuff? Great. So
are you thinking that like it's kind of using multiple bases simultaneously somehow to do arithmetic, regular arithmetic that's not modular?
probably. So in the grokking modular addition case, it did use a bunch of, so base here can mean 2 different things. There's like, the model is thinking in base 100, but it has different frequencies within that. And then there's the model is thinking in base 5, and this is represented as frequency 20 in base 100. But really, it's like base 5. And I have no fucking clue what the model is going to do, but I'm interested. And this is a graph worth keeping. All right, so going back to like actually forming a plan of attack after that like half-hour-long tangent. So I do still want to figure out, can the model do arithmetic? Which I think will involve setting up basic utils. And then I want to answer questions like, how does information flow through the model? For which I want to do residual stream patching for like every layer and position. In order to see like in which residual streams does the model store the information. And yeah, those may be the 2 interesting questions here. And I can break this one down into like 2 totally different numbers. First number the same, second number the same, and try to figure out what's going on. All right, and so that will tell me something. But I'm just going to do both of those things, and then I'll figure out what to go to next, because they will probably teach me things and weird shit will happen. So let's define a make prompt function, num prompts, num shots. And yeah. Oh, wait. I should not use range as a variable in a function definition. That is bad, and Guido van Rossum will appear and tell me. So yeah, I guess one messy question is how much I want to be saying like, sorry, one messy question is how much I want to be saying, let's have the same previous two-shot prompt or just like different two-shot prompts. Probably I'm just gonna say, let's have batch size 20 and generate some fixed prompt of size, some 20 different two-shot prompts, but then patch between a bunch of stuff with the same two-shot prompt. Because there's some dumb shit where you like don't want to overfit to your prompt, but you also want to like not, you also don't want to have like too many variables moving around. And this is probably the best compromise. And yeah, so I'm currently just doing boring coding. So it's possibly a bad use of whatever. That seems pretty coherent to me. Yep. Why is this sad? But whatever. So yeah, I'm currently just like running the model on the logits. I'm turning to running the model on tokens and trying to understand what's going on. And seeing if it can like probably get the right answers. And yeah. Yeah. Oh, wait. An incredibly annoying thing is going to be that if I rerun this cell, then that will just reinitialize everything because I don't have a fixed random seed. And the stupidest way I can think of solving this is to just be like, that. Great, life is good, everything is deterministic. There's no way this will fuck me over later. What? I'm just going on a minor tangent to make my plotting library actually support BF16 because I just never really got around to it. This is an extremely exciting tangent that I'm sure everyone will enjoy and get a lot of value out of. But yeah, I'm doing things with pip install editable so I can go and just edit the library and make things not suck. And yeah, this is a bug I've run into a few times and it annoys me, and this is probably worth the effort to just fix. Bah. Um, But why is this? And restart my runtime. Maybe this will magically fix all of my problems. All right, well, that runs. So yeah, this should just be sanity checking that what I have works. And I now want to set up residual stream patching. And so, yeah, let's call what I currently have my clean tokens. Then I guess things I might care about having. Having a totally different X. Sorry. Yeah, I'll want corrupted X tokens, corrupted Y, and corrupted both tokens. And let's just define this manually. Oh, wait, this is completely the wrong code. Lol. Oh man, I already have it cached. Why is it taking this long to do? Stupid code. Ages. I should probably try to avoid fucking up my imports and needing to reinstall again. But I can survive. So, where was I? How is this taking more than 3 minutes? This is bullshit. Possibly because I'm making it do the LAN unfolding on the CPU, and that's slow and makes it sad? Or possibly something weirder and more confusing is happening. Ah, well, I should just write code. Anyone have any questions about what's been happening so far? Or like plans? While we wait for my stupid notebook.
No, thanks. I have to head off anyway. But thanks for that. It was really cool.
Thanks for joining.
I look forward to finding out what you find.
Yes. Plan. Make sure I have a plan that I can actually get good answers on in 3 hours. It's not necessarily going well, but whatever. I'm curious. So I am generally a fan of just coming up with random functions I'm going to be putting everywhere and giving them glorious all caps names. It's so cuts, but also shockingly helpful. Oh my God, things are working. What on earth is going on? I'll take it. The model actually kind of knows what it's doing. I'm very impressed. I have no idea why it fails on that question specifically, but why not? All right, what I think I want to do is filter for things where the model like actually knows what it's doing, because likely the things are going to be a lot cleaner when I do that. So yeah, let's give it like 50 prompts.
Wouldn't filtering result in mostly prompts where the model has just memorized the answer?
This is a fair concern. I guess if I look at things like this, it's like, okay, the model knows 161 plus 107 is like 268. I'm like, I'd be kind of surprised if it had memorized that. That's just a striking thing for it to have memorized. And like, to the degree we believe there's a real algorithm here, it seems like it probably should. Okay, there's like things that I think it would have memorized, like 100 plus 200 equals 300. Probably memorized. That's boring. And then there's stuff that's like not memorized in interesting ways. And then there's stuff the model just totally fails at. And I'm like, I want stuff between totally fails and the model knows what it's doing. And I guess one interesting question would be on this prompt, which I guess is the -5 prompt. What is actually going on? Where it's got like an off by one digit error. Huh. The kinds of errors it makes are fascinating. It's like figured out the answer should be 6 mod 10. Almost figured it out what it should be mod 100, but like a little bit off. It's wild. Anyway, I think I want to give it 50 prompts and then filter for things that it gets. And now filter for things where the final dimension is equal to the answer tokens. And let's do a scatter plot. I use PLPs as a shorthand for predicted log probs, which is my name for the log prob of the thing that is actually the answer, which I feel like there should be an actual name for, but I've yet to come up with. Possibly CLP for correct log prob is like the right thing. I don't know. All right. I'm going to filter for P prob bigger than 50% and is top answer. Great. All right. Let's just do all of this again. This is done with the absolutely magical Command D shortcut. That is my favorite ever command shortcut. You just highlight something. You Command D, you get a cursor on the next occurrence. It's magical. And wait, this code is going to be cursed because, yeah, this code is going to be cursed because after filtering, I'm going to change what the lists are. Why does VS Code interactive mode sometimes just forget lines have been ended? It's outrageous. All right. So I was writing a bunch of random code and I got very distracted. All right. Model is pretty good at doing it with a corrupted X answer. I feel pretty happy with that. I'm just constructing a block of tokens where the block of tokens is like the same, but the X is messed up. It's verifying. Yep.
What exactly are you corrupting?
So X, by X, I mean the first thing in the actual prompt bit, and I'm replacing it with another randomly chosen number. And I'm going to repeat this for corrupted Y. Where via the glory of command D. Hopefully, the main lesson to take from this is that real research involves a lot of like writing bullshit, tedious code. Does this one work? Beautiful. It looks fairly coherent. Possibly I should also filter this for the prompts that work, but that just sounds like a lot of effort, and I can't really be bothered. Yeah. Oh, wait, crap. I should be making this deterministic too.
I have to get going, but thank you.
No worries. Hope this was of interest. I appreciate your dedication, Lovis. Wait, is that how to pronounce your name?
Lovis, yeah.
Lovis. Yeah. Oh, maybe the thing I should do is this. So they always have an initialized thing at the start of each set. Incredible. They actually look the same. Life is good. It's not even. Oh well. That sure looks appropriately corrupted. All right, so now I want to do core both. plausibly, I should be generating a different set of things for this set of product stuff, but I don't actually care enough. Well, that sure does not look legit. Huh. Why does that look terrible? What the fuck? Okay. Oh, it's because I replaced it with the actual number rather than the token index of the number. Wait a minute. I forgot that VS Code started doing this. It's so magical. I can just look at the value of variable on hover. It's fantastic. Anyway, I should stop procrastinating. But all right. So what I can now, first let me just check, am I in any danger of ooms? Oh, wait, shit. I forgot to do torch.set grad enabled false at the start. And if you don't do that, then it keeps around everything in memory, just in case you might someday need it. It's incredibly obnoxious. And this screws up your memory. It's so bad. I live in eternal fear of getting GPU ooms or add memory. Amazing! It's down to 25 gigabytes. The magic of disabling gradients. I hate that this is the default thing that Torch has on. It's so obnoxious. All right, so the thing that I'm trying to do is patch the residual stream. And so I can just be like, or pause in range -5 to -1. Why is this? Oh. No, I want to do -4. Oh. Okay, so what I want to do. I want to, okay, I should write out a bunch of boilerplate code. So that is defining a bunch of constants that are useful to just have in my namespace. I now want to define my patching metric. And for this, I think I want to just take the so the two natural things my patching metric are like the prob and the log prob of what I'm looking at. That's right. The log prob of the correct answer or of the incorrect answer, which is nice because it basically just tracks how far you get the thing you care about. And logit difference, which is like particularly nice, the difference between clean and corrupted correct answer log probs, which is really nice because it's also the difference between the logit, which means it's perfectly linear and beautiful and a linear function of the residual stream. But also here, I think it's somewhat cursed because it's, sorry, Here, I think it's somewhat cursed because you don't know the difference between the exact value the corrupted answer is set to in terms of log prob is like not super interesting. You just know it's going to be pretty damn low. And so when I looked at it before, it became screwy. So I'm going to make my patching metric the clean log prob. And oh, let's just rerun this. But oh, great. That's what I want to see. The average clean correct log prob is 0.23. Wait, that's unreasonably high. Let me check that. All right. I guess it's just really, really good at most of them and okay at some of them, and this averages to 0.23, which, no, what is 0.23? Oh. That is 80% on the right answer-ish. Admittedly, averaging log prop and then exponentiating it is kind of cursed because that's very different from exponentiating and averaging, but like, who cares? No, we got time for that. blah, blah, boilerplate. Let's do the residual stream at the start of each layer. Really make the transformer lens interface for this a bit less janky. I at some point went back and actually added utils for doing a patching sweep, but I don't think I made it so you didn't need to iterate over every single position, and that would just be like 4x slower here, so I can't be bothered to do it. And yeah, general motif that I like is using partial to define the hooks. Since it set it to nice variables, it becomes a single function. Why is my linter sad? Is this? No. It's still sad. I don't care. What? Oh. I really should fix this too. It needs to be a tuple because otherwise everything breaks. Because obviously the use case to design for is when people input a long list of hooks, because that happens ever. That was so quick. I was expecting this to be ridiculously cursed. Okay. So observation 1 is that, wait, yeah, what? How is that so quick? It also occurs to me that probably I should do all of this in float 32. And also, and that I should figure out what the baselines are.
Just to summarize, maybe the idea currently is we take the corrupted token, we patch in different things from the clean cache and see where we can raise the log props of the correct answer.
Yes, exactly.
Nice, makes sense.
And yeah, so, and yeah, we want to see how close things get to the clean baseline. The clean baseline starts at a really low amount. Or yeah. Okay, so one question is like how to set the scale of this graph, because like it kind of looks dumb. Or so it's like I don't think I care that much about how the answer goes from like -13 to like -7. But I care a lot about how it goes from like -6 to -1, pulling dumb numbers out of my ass. So I think what I want to do is plot the negation of this. I don't know, thinking about careful details of plotting is secretly the only real important Eckentard skill. Um, it just says force it to be between low and up. Beautiful. I think. Possibly I should not have my plotting logic in the same cell as the sweep. Cool. All right. This is good because now I can hover over things to see what the value is. Great. All right. So this tells me that things move from X to the end around this layer, and that there's a couple of crucial attention heads. Seems like a win. And that was insanely fast. So we can run it on things. It'll be hilarious if it doesn't get transferred around this point. Oh, good. Interestingly, it gets transferred at like a somewhat different rate. But like, whatever. It's all making sense so far?
Yes.
Great. All right, something more interesting. Ooh. So my interpretation of this one, though, let's redraw that without, yeah, let's just like redraw this one without the offs, with the offset at like 15. Oh, wait. Yeah. So there's, okay, let's just get rid of the offsetting bit. Cool. All right. So the interesting thing I'm getting from this is that this tells me that the equal sign retrieves both the X and the Y and adds it there, rather than, say, addition happening on the Y. And
Yes, because if both tokens were present at the Y, we would have higher log props there.
Yeah, exactly.
Makes sense.
Residual stream patching is like a measure of like, where in the model is there sufficient information to do this? And just having X and Y in the same place is sufficient. All right. That was interesting. That was really fast. So let's just repeat that for, I don't even know.
be cool to see what happens if you add 3 numbers together, if it does like a partial sum at the second summation sign.
It's a good question. It would not surprise me if it's just like completely incapable. It would not surprise me if it just cannot do triples. But I don't know. It's a good question. Let's try it. I don't know. Let's give it 2-digit. No. Oh, let's make it 40 to 100. So the output is always 3 digits. And let's make a 7-shot. Beautiful. Probably looks like real arithmetic. Yep, that looks pretty correct. Not bad. Like highly uncertain between multiple things, but this does include the right answer. Fine. Is that an understandable mistake? Okay, so it's just kind of guessed. Well, I'm adding stuff, so I should probably carry 1. Just like not an insane supposition when you think about it. Well, that sucks. Well, I'm becoming less impressed. Well, that failed. I feel like the first few just got lucky. All right, I'm going to go with it can do it better than random, but not great. But there's probably some real circuit there. And let's see. I would bet that if we gave it like 2 to 30, that it would get much better. Well, nope. No. Yeah. Oh, it's because it's got 27 and 27. It doesn't want to have the 6 or something. What? What? It's I don't know, man. All right, prediction falsified. I have no fucking clue what's going on. It's like it's doing something. It kind of knows what it's doing. Also, I'm procrastinating.
Yeah, but it also doesn't look like it's just adding 2 of the numbers. It's weird.
Yes, it occasionally looked like that, and then sometimes does not look like that. It's bizarre.
But it is kind of in the right ballpark, not off by 100 again.
Yeah, it's fascinating. All right. So, okay, so let's rewrite this to be to just have like a stack of tokens. Okay, so what am I doing? I'm just trying to rewrite the above so I can do all 3 of them at once. See, does anything happen if I stack this many decorators around each other? TKDM is what gives me this beautiful progress bar. It's taking like 7 seconds per one. I should be going much more aggressive on the number of prompts. Oh, all right, that's what we had before. I am kind of curious whether there are attention heads that specialize in like the X and specialize in the Y. What? What? Ah, okay. I think probably what's going wrong is that no one MLP is enough to get it above -6. Apart from these, which are basically just the embedding. Or at least, presumably, a thing that often happens in models is they treat the output of MLP0 as like effective embedding. Wait, no, GPT-J uses parallel attention. So MLP0 can literally only see the embedding. Parallel attention means attention layers and MLP layers act in parallel rather than in sequence, which means MLP0 can only see the input token. And it's so sad. All right. Let's make the offset log of like 12. Cool. Okay. This is looking much more reasonable. It's like, okay, no, this is stupid. I should just stop doing my weird, messy color schemes and just do this like a normal person. Oh, wait. How do I want to do this? Cool. I'm happy with this. Yeah, this graph is showing me the clean lock prob with white set as -15. And yeah, things that were annoying me about all of the others is I want white to correspond to like neutral or nothing. And that just wasn't really working on any of them. And it was sad. Okay. These are cute enough to want to take screenshots of them. Cool. All right. And yeah, important info is concentrated in these MLP layers, but it's not like a massive sharp spike at 20, which is about what I expected. All right. So
And 20 is where the paper found the most contribution, right?
so the paper seems, so they seem to index at 0, and they seem to find an enormous thing at 20 and a little bit at 21. Well, what I found, and yeah, and specifically addition, it's like 20 big, 21 also pretty big, 19 non-trivial. Well, what I found looks more like, well, 19 big, 20 a little bit smaller, 21 a bit smaller than that. I don't know. I'm using logprob, which I think is like a fairly sensible metric. They're using this, which I don't know how to interpret. And it's like involving probabilities and involving ratios of probabilities in a way that I think tends to sharpen things and make them like less weirder. So I'm just going to label this as like, I don't really know how to interpret their analysis, but I somewhat know how to interpret log probs. So I'm going to roll with this. All right, so I guess one sanity check to have is like, if I patch in the layer 17 to 23 MLPs, how much performance do I recover? Wait. No way, I should probably check what the attention does. Cool, all right. There's some heads around here. What? What? Is that just some specialized head for specifically retrieving for X? What? What? All right, whatever. So, yeah. Yeah, so the range, which seems to be matter, is like 14 to 24. Pretty fucking legit. It's like 0.3, basically perfect. If I tighten the range, basically fine. 17 up to all right. How tight can it go?
What's your threshold for that's bad now? Probably this, right?
I don't even know what the threshold is. The main thing that I was finding interesting is that it seems, I want to call it non-additive. Like, this is terrible. This is like pretty damn good. Yeah, I don't really have a principal threshold here. If I did want to have a principal threshold, it would probably be, does this equal the clean answer tokens? Which is a thing that I could print. You convert it to a float because PyTorch can't average pools, apparently. Insane accuracies. Oh, who lists does this thing have? All right, so if I patch everything, it does pretty great. Accuracy starts to degrade a bit. Yeah, I don't really have a principal thing that I'm doing here. I guess I'm like, well, that seems to have like, that's like something real, and then like, meh. Unconvinced. Okay, so what now? So the next natural question to ask is, what's the direct logit attribution? And yeah, what's a good way to do this? How fucked is my GPU cache? It's already 28 gigs. Wild. I should like 10x my batch size or something. Bad. Oh. Mm. Ooh. That's fascinating. So this is the direct logit attribution. And from the clean, and what this seems to be saying is that, all right, so there's 28 layers. It's saying there's a massive spike from like the final MLP layer, which I'm just going to tentatively label as random garbage from some kind of extended unembedding and mediation, where it's not like doing actual computation, but other things are like writing to the corresponding subspace. And yeah, so, but then there's a bunch of MLP layers all kind of writing to it. And this also corresponds to the band of MLPs that seem to matter, and about to the degree that they mattered. So I'm just going to go ahead and wildly speculate that the MLPs are like directly writing to the output, but also mediated via the final MLP. And I can't bother to check this, but it's probably fine. And a thing to look at is what on earth is up with this head? So let's look at its attention pattern. I'm not sure I actually think this is a good use of time, but whatever, I'm curious. There's this really stupid thing where Plotly if you give Plotly string labels for the X and Y axis, it like assumes lol, okay, it's self-attending. This is probably not interesting. Yeah, there's this like kind of obnoxious thing where you give Plotly a list of string labels and tell it to do something with it. And it's like, oh, you have multiple things that have plus. Surely these should be the same element. And it merges them, unless you have something disambiguating them. A friend of mine has the glorious hack that he adds different numbers of Unicode characters that get rendered as the empty string. It's absolutely incredible. It is some of the worst coding I can recall seeing. All right. Okay, so the head is basically just attending to the current token, which makes me predict it's some kind of like mediation thing, but it would be interesting to like actually confirm.
What do you mean with mediation thing in this case?
So yeah, I'm kind of using hand-wavy jargon to mean things I don't understand. So the intuition in my head is going to be bits of this that are like doing real computation, and there's going to be bits of this that are doing random garbage. Or like, they're not doing computation, but they're just some fixed circuitry in the model that takes existing computed things and like transforms them in boring ways. That isn't the core addition I care about. And my guess is that this is an extended unembedding, where it's just like, rather than having a linear space for unembedding, the model uses this MLP to expand out some space or something like that. And that this is a head which is just signal boosting certain things. And an interesting question would be, what's the standard deviation of its attention patterns? Which is like, it's 0.6, standard deviation 0.2. I'm going to mostly call it a thing that just attends to itself, rather than a thing whose attention pattern is like doing a lot of computation. Though this is kind of a fuzzy subjective notion, and it would be very reasonable to say, Neil, you're being ridiculous. And anyway, the thing which I am curious about is that
So you basically mean the head could be saying something like, I should probably output a number or things like that.
Sorry?
When you mean like it's signal boosting, do you mean the head could be doing things like, I should output a number and just boosts all number tokens?
That is, so there's two different ways to think. What? Why is someone ringing my door? Be right back. Someone had the wrong flap. Yes. All right. So yeah, I guess a thing which I probably should do is plot the direct logic attribution of like, I don't know, 127 as a stupid baseline. Yeah, where I'm just like, what things output numbers? Cool. All right. So this bit of the model sure thinks it should be outputting a number. That's boring. What if I change this to some other magic number, like 273? Where I'm really relying on my ability to magically generate random numbers. Ooh. Now this head's doing something. I don't know, man. Yeah, the thing which I wanted to check was what exactly is up with this. Why is this sad? I'm trying to be unnecessarily clever. And ah. Ah. I should just do this with Einstein. All right. So I'm trying to figure out what gets mediated by this head. And it's basically just a bunch of MLPs. I also cheated and included everything after layer 24 as well. And we see a massive spike, which is just the head, suggesting it's doing some kind of copying. And then a bunch of this stuff. And I'm like, cool, not that interesting. Though we also interesting to look at the eigenvalue God damn it. All right, I don't care. Yes. Okay, so we have a bunch of MLPs. The output things that get directly added to the right thing. And
sorry, but what exactly did you do with that last code cell?
what exactly did I do with what?
The mediated head in the last code cell.
Sorry, so what I did, this is a bunch of bullshit matrix multiplication. But so basically what I did is I took the stack of residual stream components decomposed into each head in MLP layer, and then I multiplied it by the heads of the matrix, and then I multiplied it by the like output vector for each correct answer. Does that make sense?
So that's basically what the head would output at different positions.
Yes. No, sorry. So the head's output is a vector. But if you condition on its attention pattern, then the head is just like, sorry. Let me solve this again. So if you condition on the head's attention pattern, it's just linear. The residual stream that goes into the value bit of the head is a sum of components, and these are then multiplied by the AV circuit to get like the output, but you can expand the output into the contribution from every prior component.
Mm-hmm.
And yes, and then you can look at the head's direct connection to the output logics, and you're like, what is this head reading from? And you're like, okay, it's reading from the layers that we thought mattered. And it is
okay. So we basically decompose the head output into all the possible inputs it had to see which input made the contribution to the output. Makes sense. Okay, thank you.
I wouldn't quite say every possible input. I'd say the sum. It decomposed the input into the summable components. And
yes.
Linear, that decomposes the output. Yes, I don't know. I feel like a thing that people often just don't appreciate is how insanely fucking convenient everything being so linear is. I don't know. What's up, Wes? Yeah, so we're trying to understand how GPT-J does addition with its MLP layers, taking prompts of the form and
so few-shot prompting.
Yeah, few-shot, because everything between 0 and 520 is a single token, conveniently. And the main interesting findings so far are that if we do, so we've got 3 different corrupted things. Here I'm just looking at like 33 prompts because I'm lazy. We corrupt the first term, we corrupt the second term, we corrupt both terms. And when you corrupt the first one, and you look at the residual stream, you see it gets moved over around here. And you corrupt Y, it also gets moved over around the same time. And you corrupt both, it's completely doomed. The metric here is 6 plus log prob, because I don't care about it if it's below -6. Well, if you have both, then it only appears here, which my interpretation of is that the addition is happening on the final token, and it is never sufficient to have it here or here. In contrast to the hypothesis that the addition happens on Y,
Mm-hmm.
which I put like at least a third on going into this.
Yeah, that seems unlikely because like at the Y token, like if you think about what the language model is trying to predict at the Y token, it could just be like the continuation. Like Y could be a multi-token number, and right,
Okay.
like the equal sign induces the addition operation.
So I maybe agree. So I think the fact that Y could be the first thing in a multi-token number checks out to me.
Yeah.
And that makes me, I think, agree with you. I don't
mean, if you see X plus Y, you're never going to say what X plus Y is unless you see an equal sign, right?
Well, you might just say X plus Y is, right?
Sure, but then there's an is token, right? My point is that there's
Yeah.
always like some indication that that you should complete the operation now.
So I think this is fair. But on the other hand, if you had something like Michael Jordan plays the sport of goes to basketball, my guess there is that the fact lookup is on Jordan, and then the like fact extractor on of just gets the fact rather than like getting Jordan and then looking up the Jordan sport fact.
So I agree with that. I don't really think that it's incompatible with this observation, just because like the numeric value of Y is still exists. So that's like the analog of like outputting the fact. Like the numeric representation exists within the residual stream of X and Y, but like there's no reason to add them until you get to equals.
There's like reasons it could be convenient. It's also like, well, maybe you have X plus Y, and you have like multiple downstream tokens that all need to know what the answer was in order to do something. Anyway, whatever. I would have bet that this was the case, but I would not have bet that more than 2/3 of this was the case. So I consider this interesting.
This seems, yeah.
And anyway, yeah, attention, not super interesting. The one cute thing is, yeah, there is some early attention that's moving the key things over. One particularly cute thing is there's a head that really matters in layer 24. And then when you look at the direct logit attribution, what's the direct logit attribution? You're like, why does this head matter? To which the answer is obviously that the model has just learned to do addition via a head, as is only reasonable. But the answer is actually that the head seems to like mostly just attend to the current token, and I think mostly just reinforce the MLPs. And then when you zoom in on the MLPs, it's kind of a headache because there's this like bump of MLPs that also shows up in the patching thing, which is where I think the like actual real computation happens. And then there's like this fucking thing.
Whoa. That's the last layer?
Final MLP layer. And I'm mostly just going to be like, well, that's probably an extended unembedding I don't need to think about.
What's the intuition here for an extended unembedding for
First
numeric?
layer is always weird, man.
So
in particular, the bet here is that it's not where the addition computation happens, though it might be part of some translation from the addition computation back out.
Right. If it's in some weird representation or something, it's like,
yeah,
this is the token value of this representation.
Yes. And I don't know.
How good is the modular addition?
We gave it 50 things, and of those 33, it had log prob above 0.7 and had it as the top answer.
Oh, that's pretty good. Are you doing like any sort of MSE thing where like if it's off by a little bit, like that
Nah.
still kind of counts?
Also, check it out. It's like off in interesting ways.
Well, that's why this might be, yeah, it might be worth having a better metric.
Nah. Oh, wait, fuck. What is this thing with pen spaces? Who designed this? Well, rather, why did I design this? Anyway.
Oh, so it knows, oh, this is cool.
Yeah.
So it's clearly like a base.
Yep. Yeah, we had a long tangent looking at Fourier terms in the embeddings,
Yeah.
which was very fun. The cutest thing is if you look at the embeddings of the tokens from 100 to 500, and then look at how much the model is representing like different like waves of different frequencies with period dividing 400, you just get lots of cute spikes, like at 40, which corresponds to a wave with like 10 periods, and 80 with 5 periods, and 100 with 4, and 120 with like, I don't even know what.
Huh.
And a third, but this is messy because it doesn't really divide gray into a third.
I wonder if you could predict its errors based on like these sorts of curves.
Probably, I don't know.
Cool.
Yes. Anyway.
Okay. Yeah. Carry on.
All right. Now I need to do the hard bit of figuring out what the hell is going on. Which is the annoying part.
What's your hypothesis?
So my hypothesis is there is a single pass of computation such that my hypothesis is that there is a single pass of computation spread across like 6 adjacent MLP layers that takes in the numbers represented in some like cutesy Fourier thing and does addition on them. And probably it does addition on the base 10 part, and it does addition on the like mod 100 part and combines them somehow. And I don't know whether I expect there to be significant composition across the layers and how I like kind of predict it's using something somewhat like the Fourier circuit I found. The main thing I'm unsure about is like how it's dealing with bases and how it deals with carrying.
Yeah. Yeah, like I wonder if you could localize the like base 10 versus like the base 100 circuit or something like this, right? Like if you looked at the error mod 10 versus like the error mod 100 or something like this, if like those are distinctly different.
Yeah. So that is a good question. So honestly, wouldn't massively surprise me if there's just two kind of boringly different things going on here, where you have like there's like the world where it's doing addition mod 10 and addition mod 100, And the mod 100 is purely used to get the like 10 digit. And there's a mod where it's doing addition mod 10 as like a separate backup, and then doing the main addition mod 100. And then like adding the mod 10 bit on top or something. And I have no idea. Anyway, I guess one thing I should obviously do is take the I am a number unembed. And just subtract that off. This is just being like, well, there's going to be an I'm a number direction. I don't care about that one.
Yeah. Yeah, but based on like the error analysis, it did look like there was like a ones place feature, a tens place feature, and like a hundreds place feature or something like this.
Wait, is this called error analysis?
Oh,
that's hilarious, Jug.
I mean, I wouldn't. Yeah, error analysis refers to a lot of things, but like, yeah, seeing like, yeah, what errors your models make, and it's like suggestive.
Nice. Anyway. Okay, cool. So centering by the thing is like boring. But I just removed the I'm a number bit. And wait, no, that is not boring. Let me just add a y equals x. That is not how you spell true. Huh.
Oh.
Oh yeah, cool. This is just the observation, but the final MLP outputs a bunch of like, I'm a number. Crap.
Right.
While what? Why is this a straight line? What the fuck is going on? Okay. So all right, new plan. I want to get the probability. I want to get the like direct logit attribution for the thing minus all other numbers that share the same zero, like the same units, tens or hundreds digit with it, as three separate things. Cool. All right, that's a number. No. Oh, lol. What? What? Oh, wait, what? Oh, that makes sense. Huh, that's highly variable. Probably Wes would say I should do a box plot for this.
Probably.
So unreasonable. Nope.
No.
Um. Where I've gone poly box plots. Whatever, I don't care.
Hold on, what are the shapes here? What is 33 by 478?
Batch size, num components, including every head.
I see. Okay.
Really, I should get rid of all the heads because heads don't matter. But oh, wait, no, what? Yes. Huh. Interesting. What? So it's like MLP 25 and 24 are substantially responsible for units, and 23 a little bit, and the other one's mostly not. Does this seem like a legit interpretation to you two?
I think so.
Wild. I was not expecting anything as clean as that. All right, let's do that again. The tens.
Yeah, wait, so this is the ones place?
Yeah.
Cool. Wait, and so those were the last layers rather than like the first layers that were implicated?
Sorry, say that again?
Those were like the last of the layers in the addition.
Yes.
MLP. Okay.
Yep. And importantly, if you get rid of those, it's still fine in addition.
Right.
This is fascinating. Especially that 25 goes from like matters a bit to just, nah, I'm out of here. Actually, so I guess what I'm doing here is also implicitly centering, because I am subtracting in like I'm a number direction as well. And this gets much, much worse when you subtract the I'm a number direction. It's like, why does it not get much, much worse when you subtract the I'm a unit direction? Anyway. It brings me great joy to have a variable called 10 that can never be equal to 10. Okay, new plan. Compare things to centered stuff. What? So the hypothesis I was trying to test is that layer 25 is actually just realizing it should be a number. And the reason it gets terrible when you tell it what the digit is that it's like, ah, nah. But like, nope. What? I'm so confused.
I mean, presumably layer 25 is doing many things.
I mean, maybe it's not that big. It's only got what, like 20,000 neurons? Yeah, 16,000. Like nothing. It's fine.
Yeah, what could it possibly be doing with all 16,000 of those neurons?
Yeah, well, detecting French on 16,000 times or something.
Yeah.
Something boring like that. Anyway.
Don't you have your fancy like per neuron logit attribution utility?
Yes, but it will melt my GPU.
I see.
I mean, I can check.
I mean, I would be curious of a histogram of that. I would
Sure.
I would want to see that.
Sure, why not? For one layer for you, I can make it work. So, all right, so we want to know why MLP 25 has high centeredness. Yeah, it's just what? Okay, I'm just going to assert that there is not some like clear distinction into learning the different things. Anyway, all right, so for layer 25, let's say that W clean, let's study W clean centered. I really hope my results aren't just like lol floating point errors or something. That would be hilarious.
Wait, where would the floating point error be?
Oh, I'm using bfloat 16.
Yeah.
Everything's doomed if you're using bfloat 16.
Is that true? I don't think it's that doomed. You would know if you took numerical analysis.
I don't know, man. I looked the other day, and sometimes the transformer lens logits differ from the Hugging Face logits for a Python model by like 25% if you're in bfloat 16.
Holy!
But not if you're in float 32.
Actually, yeah, I get lots of nans when I run the Pythia models in float 16.
I
No,
found
I know you need to use bfloat 16, but yeah,
no. I have a different app. So I found this great bug in Pythia 70M and transformer lens, where sometimes the model would look into the future with the attention patterns. Does anyone want to guess how this bug happened?
Did you like set negative infinity and it was like different for like different like types or something?
No. So what I did is I cargo cultured GPT-2, which rather than sending negative infinity, set minus 100,000. And I was like, sure, nothing will ever have an attention score that is less than minus 100,000. Turns out Pythia something has attention scores of like minus 160,000 for some bizarre reason. And that this breaks the attention pattern code. It's amazing.
Wow. Do you think that affects like literally anything?
It means float 16 kills everything. But like, I don't know, there's like different destination tokens have like very, very different constant offsets. It's like one of them is minus 60,000, the other one minus 160,000, one of them is minus 10,000. And if you center them, they look much more reasonable. And it's like, what? Why? How? Models, man. Anyway. Ooh, there's an optimized keyword. Not looking amazing.
Wait, why would that melt your GPU? That's not bad.
Oh, it's doing the full thing that melts the GPU.
Oh, across all neurons.
Yeah.
Oh, okay, yeah, sure. Let's see. Yeah, this looks not all that interesting. I mean, I guess it, I mean it. Ooh. I mean, they're definitely those are heavy tails.
But it's like not overwhelming.
It's not overwhelming.
Yeah, what happens if I just do uncentered?
Oh, that's better.
Oh, wait, no, but because it's uncentered, this tells me that there are some things that have just realized it's a number.
I see. Yeah. Yeah.
Anyway, I'm going to rule this as not super interesting, but I am now pretty curious about other layers. And yeah, let's click with centered.
Well, under your hypothesis that layer 27 is mostly just doing I am a number stuff, you would again expect even heavier tails when you uncenter it, correct?
Sorry, say that again?
Because your hypothesis was that layer 27 is primarily just outputting I am a number.
Yep.
And so if you use the uncentered version, we should expect to see an even more extreme effect of what we just saw of the heavy tails when you uncenter it.
Sorry, say that again?
Just do this now with uncentered.
Sure.
And we should expect even heavier tails.
Yep.
If it's the case that layer 27 is primarily just saying I'm a number.
Sure look like some heavy tails.
Yeah. I don't know if they're heavier though.
What? What?
No, as compared to layer 25, the diff on these two.
I think centered is just the correct thing to study.
Oh.
And yes. What's a reasonable range? 17 to 28. Ah, fuck. Wait, what? Oh, shit. Wait, no, what? That should be fine. Oh no.
Is it one you transposed? Yeah.
I mean, I'm fine, but
Whoa. Whoa.
so this is the final layer. Uh, I'm just gonna go with none of these blowing me away. Okay, there are some neurons that like genuinely do matter. But damn it. What? Why is this so uncooperative? I just want to be able to hover and see the extremes, man. Yes. All right. What is up with neuron 15837?
Wait, if it's on the negative range, is it decreasing the right answer?
This is a good point. What is up with neuron? What should we call it? 10,060. I don't even know what I'm looking for here.
Yeah.
Also, this is a sign that I have too many graphs plotted and should declare bankruptcy. Wild.
Oh, is this across the batch dimension? So there's just like one thing where it really affects it.
Yes. Ah, okay. New plan. Oh man, what was the neuron name?
Yeah.
So this is the direct logic attribution of the neuron weights against the unembed for like different tokens. And it's like solidly periodic.
Are these like numeric tokens?
Yep. Oh,
Wait,
wait.
the first 520?
Shit, good point. Wait, that still looks correct. A sign that I'm reading tea leaves.
Yeah, maybe a little bit. These
Okay,
are like
okay,
the
okay.
letters.
What? God damn it. What? Shit,
Is it torch dot shuffle?
I tried that.
No, you did torch dot random dot shuffle.
Oh, good point. What? What? Oh.
Oh yeah, it doesn't return.
This is bullshit. Why is it so hard to shuffle a fucking list? That's so much less periodic.
Yeah.
When you're looking at this, I can see a little bit of it. Well, it's so spiky. I kind of break a little.
Just do the number tokens.
No, I feel vindicated. That is more periodic.
It is more periodic. I'll admit.
Oh, man, do I even have a list of number tokens?
Number token index, yeah. Whoa!
Whoa!
Whoa! Talk
That-
about periodic. That's the 100th place and the 10th place.
Okay. Now, oh man, what is the right way to interpret this? Okay, so I don't care about how it impacts the first 100. So let's restrict to and yeah. So this is definitely sparse in the Fourier basis, which is non-trivial. And it really likes terms.
Multiples of 4?
What does this even mean? What does the sign for term? That's like 8. Okay. Cool. Okay. It likes things which are periodic mod 100. And it probably likes things that are smoother rather than very spiky, which checks out. But, huh. Okay, here's a new question. If we take the Fourier terms over the output. Also, I can stop doing this to have our check-in at some point if you want. This is more fun.
This is fun. I mean, I do like have stuff to talk about, so.
This is our check-in. You've agreed.
No.
I'll stop at some point. But
Okay.
I am not done with this.
Yeah, no, this is fun.
Moles. Second. Great. All right. What is even the interesting range of layers? Is this an interesting range of layers? And let's include layer 21 as well. Okay, but oh, sure. That is actually a reasonable complaint. Okay. I hate this. Okay. Is there a reasonable way to interpret this? Okay, so the first observation is that I should normalize this. Oh, thanks, Copilot.
Should you actually? Might there be information in the norm?
So I think I want to look for important neurons, and I feel like I want to look for neurons that are relevant to this task. And I think that having
Oh, sorry, this is W out. No. Yeah, W out. I agree, should be normalized. Yeah,
Right.
yeah. Sorry, I thought you were normalizing the product.
You are forgetting. Yeah. All right. So what's the right way to do this? I can just take a term like
Well, so what would you expect to see if it wasn't periodic, or like it wasn't sparse in the Fourier basis? What's a summary statistic of that, and then maybe sort the neurons or something.
it's a good point. That is a better idea than the random crap I'm currently doing. Woohoo!
Oh wow.
That works.
Yeah. Wait, sorry, what is y here actually?
Sorry. So y here is the dot prod. Okay, I should divide by the norm of this. So what I did here. So this is cosine lim of the neuron output weights with the sine 8 Fourier direction.
Oh, cool. Okay. So these are neurons which are outputting in a relevant Fourier direction. Okay.
Yes. And I don't even know what I think because there's something to do here. So I guess one thing worth checking is the okay. So like a good chunk of this is like, well, we should probably remove the I'm a number term.
Wouldn't that be constant in the Fourier basis? Or do I not know how Fourier analysis works?
Good point.
I mean, you can just do it and see how much it changes what you just plotted there.
Yeah. No, I think you're right.
Okay.
Well, I mean, we can.
I would still be curious. I mean,
Cool.
oh, and it just killed the constant term.
Yep.
Oh, that's so cool.
Fourier analysis, man.
I can't believe I did Fourier analysis.
Yeah, it's almost like you're doing a STEM PhD at a top university. And
I didn't don't do any trig things.
sorry?
I don't do any trig things.
I mean, I had to look up what Fourier terms were to remind myself at the start of my grok. No, a week into my grok investigation, I was like, I guess I should remind myself what Fourier analysis is. It's probably relevant.
Yeah, just
That
sums
was
of code.
excellent
Sine
investment of time. But fucking wild.
Wow.
Anyway, so I assert this is fairly interesting. I think the metric that feels exciting to me, what's an interesting metric? So one dumb thing would just be standard deviation along the Fourier dimension.
Mm-hmm. Or the range.
Just like max minus min.
Yeah.
Sure.
Because, yeah, I mean, for something to have a high, like that implies that it's strongly periodic, right? In some, with some frequency. So.
I think I'm gonna head off.
Fair enough.
Yeah.
Thanks, Neil.
Yeah,
Bye.
this is fun. Thanks a lot for hanging around. So pretty.
Sorry, what's Y here? This is the standard deviation one?
Yeah.
Oh, STD range. Okay, cool.
Yeah, sorry. Let me um yeah.
And this is all only with respect to the 8th Fourier.
No, this is all of them.
Oh, so
This was specifically the 8th.
oh right, that was specific to the 8th, but the standard deviation are yeah. Just, yep.
All right. Wow.
So this does look pretty sparse, which is exciting.
Yeah.
Ooh. Ooh.
Huh. This suggests that I was unnecessarily conservative about which layers I was using.
Yeah.
Give this everything. I hope I don't accidentally melt my GPU.
What model is this?
GPT-J.
Okay.
And I'm renting an 80 gig A100.
Oh, so you should be fine.
Yeah, I have 40 out of 80 gigs used.
Yeah.
It's the joys of renting cloud compute. You can just get massive when you want them. Just saying. You managed to spend any money on cloud compute yet?
I have not.
Oh no. You got 2 weeks.
Yeah.
I'm sure you can productively spend several $100s of cloud compute in 3 weeks.
Yeah.
Huh. It's fascinating. Anyway, all right. So here's an idea. All right, so first off,
Yeah. I want to like sort of connect these to the other things, just like make sure those like layer 26 neurons, if you do the direct logit attribution, they're also periodic in an interesting way. Well, I guess they have to be if this is just times W out.
yeah, I mean, yeah, there's like, I've got neuron DLAs. Wow. Oh. That is a different number. Almost like there's reasons people say you shouldn't use single letter variable names, some bullshit like that.
This is not actually that connected, it seems.
Yeah, I agree. This is starting to be.
Also, wait, but these but this is only with the DLA is only with respect to 33 prompts. So it's like plausible that these neurons are important for addition, just not the 33 addition problems you have put
I
in.
agree that it's plausible that I just have stupid prompts. Yeah, this seems like an extremely reasonable argument.
There definitely are some that are seems non-random in the upper end for DLA.
Okay, so I guess I want to zoom out and be like, what matters here? What does a good resolution to this look like? Where clearly something around periodicity is going on. Clearly, there's a couple of MLP layers that really matter that are doing something important here. Clearly, yeah, clearly clearly something important is going on here. Clearly, this is not like, it's also pretty clearly not the case that it's just like, yep, there's a handful of MLP neurons doing this, and it's a beautiful and sparse neuron basis.
Wait, sorry, you said that there is or is not?
It seems unlikely to me.
Yeah.
It's that.
Where did we come down on like the tens place versus the hundreds place versus ones place being separate features?
It looked great.
Okay.
So I think so like my guess is there's just some kind of like Fourier multiplication trick identity style stuff happening here.
Yeah.
Though I am not entirely sure what the terms are.
Again, but that error analysis thing really suggested that like each significant digit was like meaningful. Or like the ones place was like meaningfully was that it got that it was like the ones place was 8 for all of the like other logits, top tokens. Yeah.
Oh, wait.
8, 8, 8, 8. Yeah, I stand by. Those are mostly 8s and 1s. Yeah, the fact that come on, that can't be random.
Yeah, I totally agree. This is not random. Though.
And then likewise, the one below it is also suggestive, right? That again, it was like maybe off on the tens place.
Ooh, okay. So here's an idea. In this analysis, I just said, has it figured out what the units should be? But what I could instead do is look at every unit, everything which agrees apart from the unit.
Okay.
Right. Okay, so what? Oh. Okay, no, this is stupid. I should. Just take. Huh. That does not seem very promising. Hmm. Okay, let's try this for the other ones.
Yeah, I still think it's a problem that this is all aggregated over MLPs. Right? Like, of course, it's going to be individual neurons, which are implicated in this. And like, we're just averaging over so much here.
This is fair. You know, I'm down to MLP specific.
Yeah. Because, yeah, I mean, I think one of the crispest results we have, right, is that one neuron that was like obviously periodic.
Yes. Checks out. It's also plausible to me that 33 points is stupid and I should have more.
This is also possible, yeah.
Wait, I'll just do that. It will mess with my results. Whatever. My GPU can take it. What's a reasonable number? Will my GPU melt if I do 1,000? Yes. Oh no.
Yeah. Yeah.
Why is this full?
You done goofed. 256 is probably fine.
Ah. Uh, is there a reasonable way to deal with this without just needing to restart?
I feel like this always happens, right? That like CUDA just like never frees itself and you just have to restart.
But it's really obnoxious.
Do you have state that is important if you're redoing the prompt?
Minutes to reload GPT-J.
Oh.
I mean, it's fucked now, so I have to do it. But I'm not happy about it.
Bad.
Yeah. All right. So the next most exciting thing is going down here and redoing this stuff. But you wanted it per neuron.
Yeah.
It's pretty doable.
And if you want, maybe filter, yeah, you can, yeah. Maybe filter it.
Sorry, what were you saying?
I mean, yeah, and maybe filtered for like the top whatever neurons.
Sure. So
What did the Belenkov paper conclude about this?
well, I'm not fairly sure what they concluded.
Oh, you have it up.
Demonstrate a small set of mentally layers have significant effect. Activation patterns. Wait, did they look? Oh yeah, they look at the top 400 neurons and compare. Yeah, I wasn't really sure how to interpret this metric.
Yeah. But it was just at the layer level of granularity.
So they did this thing of looking at the top 400 neurons.
I see. Yeah.
And I didn't quite follow the details of what they did. Yeah. Ugh. The world is confusing. Okay, so let's try to actually do this. So what is the thing that I want to have? Okay, so let's look from layer 17 to 22. I know it's so hard to tell if you're frozen or just being very, very still.
No, sorry, I was being very, very still. I was thinking, like, I, mm, what? I'm trying to just like from first principles, like how would a model do this? And like it does seem like, parallel versions of the modular arithmetic rocking thing would make sense, right? That you just like for each place.
Yeah, carrying is a bit weird. And I
So
don't have a great story of how carrying would work.
could it just be uh, yeah. I mean, for like these simple addition problems, it could just be like kind of binary yes, no, right?
Um,
Like,
yeah,
is there a carry digit?
yeah,
Or like a carry just like a bit, yeah.
yeah, I'm totally open to the hypothesis that it's just literally, yeah, you go like just carry or not carry.
Oh, you could totally train a probe on this.
Sorry? Oh,
You could totally,
that is pretty high on my list of things I was going to try next.
yeah.
Um, so, all right, you're the probing guy. What should I probe on?
Probing on if you need to carry for the various places.
What the fuck?
What?
But what has this repeated in way? This is repeated prompts. I gave it 256. It should not have this many repeated prompts. Ten.
I mean, it looks like they all start with, well, is top answer. Are they supposed to all be 100 something?
Yeah, 100 to 200.
Oh, okay.
It's like not the widest space in the world, but also like not insane. Cool. Seems good. All magically works, no one cares. Okay. So Oh. It is quite possibly bad practice to just have a long list of totally unused code in the middle. But whatever.
I'm still not convinced of this like iterative Python file thing.
It's great. What are you talking about?
Floats your boat.
Sorry?
So whatever floats your boat.
What? I don't find it. Oh,
No star. Yeah, there's a print there.
this is a reasonable objection.
Whoa.
What was that? What did I print? Oh, that was fine.
This looks a little too good to be true.
That is sparse. Cool. All right, good experiment idea.
Yeah.
Wait, okay. Let me figure out exactly what we've done before we get excited about it. So this is saying, let's purely look at the things that are figuring out what value we have mod 10.
Mhm.
Okay. That is interesting.
Can we do the DLA like per token plot for that neuron?
Do you mean the Fourier? Do you mean the weight-based Fourier one? Well, I mean, we can do both.
I think I just want it in the unembedding, in the raw unembedding.
Oh, funky. So boring.
That not boring, but it wasn't expected.
So it's definitely just like anything of 100. which in and of itself is pretty interesting.
Yeah. Wait, but why did it show up as being important for the tens place?
So, aha. So, my guess is that so let's do maybe periodic-ish.
Uh, what the hell?
So I don't know. I'm like, it's kind of striking that there is a spike at like 80. And this is mod 400. So that's basically saying it's like mod 5.
Mm-hmm. Wait, but is that borne out in this plot though?
This one.
You're saying there's some periodic structure like for every fifth element is like bigger or smaller?
Yeah.
I mean, that's clearly not like the most interesting story here, right? Like this is.
Oh yeah, I agree. But you know.
But like, hold on, I'm something isn't checking out here, right? Like, why is it that this plot, the dominant feature is a jump right around 100, whereas the way that we found this neuron to begin with was because it was apparently interesting for the tens place.
Units place.
Oh, yeah, sorry, in the units place.
My guess is it's just a very important number neuron that also is doing stuff for the tens digit, which is why I was noting like, oh, that's interesting. And like, if so, this thing, I guess it's like, well, what's the magnitude of this neuron? That's another interesting question.
Yeah, plot it on different, yeah. Well, definitely always on.
This is just like pretty fucking big, though.
Wait, but it's always on.
Is that not surprising?
That is surprising. I mean, like do that for any other random neuron, and I would bet it would not be like that.
Yeah, checks out.
Like this is something like, oh, this is like addition. Yeah. Well, okay, this neuron's never on, but
In some sense, I find it like more surprising when it's noisy, because it's like, these are basically the same font. They just have different numbers. Why do you care?
Yeah, but these are all small activation range. Like I mostly just chalk this stuff up to interference. Like
One is a big number. It's almost two.
ah,
2 is such a big number.
6 is a bigger number.
6 is a bigger number, but like, come on. I don't know. I'm happy to just agree that models and are full of ridiculous amounts of inference they need to somehow deal with.
Yeah. Yeah, yeah, I mostly chalk that up to noise.
Well, you know, this is obviously not noise.
Yeah, that is, yeah.
And so here's the thing we can do. We could
Are you going to take the average activation across neurons?
no, we're gonna be fancier. It'll be a surprise.
The median. Ooh. Yes, I like it when we make data frames. Then we can do group bys and interesting things fall out.
Oh, the only reason I'm making a data frame is so I can plot this nicely.
Oh. Well, we also like nice plots.
Seems pretty legit.
Yeah.
Wait a minute. Why? Oh, this was a
What?
okay. Well, this plot is meaningless,
Oh, is this the wrong dimension?
and we should entirely attribute this to noise. No, no, I changed it from the real. Man, I feel like one update I'm making from this whole thing is just that like I cannot read plots properly. Cool. All right, this is meaningless. This is within margin of error.
Yep. Can we do it for the other units? Or sorry, for the other places?
Sure.
Because again, this neuron was like allegedly implicated in one of these.
Oh. Stupid commas. Nah.
No. No.
I mean, I want to
Wait,
look.
what the hell does this neuron do?
This is a great question, man. I mean, okay, let me double check. It's the correct neuron.
And what was the plot that it initially popped off on?
This plot is the neuron activation times the difference between the unembed for the correct answer and the average unembed over the 10 tokens that agree with the correct answer, except on the unit digit.
I say. Yeah, seems a little sus. Maybe look at the layer 19 neuron.
And still, it's like, it's so sharp. Oh,
Yeah, why isn't I'm just maybe a little bit nervous that this, whatever metric this is just like a little bit weird. Or it's like picking up something fake.
so okay. So we are multiplying by the neuron activation.
Right. Oh, is this averaged across the batch?
Yes.
Oh, and because that neuron's always active, that's why. The neuron's always activated.
Yes. It's still interesting. I don't know. Let me
Like, it seems like this is just like is addition neuron.
sorry.
It feels like this is addition greater than 100 neuron.
Okay, so I'm a little bit skeptical. So let me do a thing that will attempt to help me be less confused. So
Yeah, I think multiplying by, well, does that make sense?
wait, what?
Whoa.
Oh, shit. Yeah, so I'm basically just like, I'm still surprised this stood out so much because we're controlling for everything except for the units digit. And so like naively, if you just randomly choose something, it should just cancel out. What?
I don't know what this is.
So X axis is like tokens between 200 and 400.
As the solution?
Sorry?
As like the solution?
Yes.
Okay.
And we then subtract the average of all things that share the same hundreds and tens digit. And we then dot product the output weights of the neuron with that vector. Oh, fuck. This is garbage. I'm subtracting J, not number token J.
Oh, yeah.
Ah,
Yeah, these subtractions are making me nervous.
this would have been fine if I hadn't had that ridiculous bug.
It still makes me nervous. Like, yeah.
Oh no.
Is this true everywhere?
Yeah. Well,
Oh, no.
it's true of this code, which ew.
And that code too.
Yep.
Yep.
Okay, so this means all of the units analysis was garbage. So let's redo it.
Fuck. I have a bad pair.
Ah,
You should be paying more attention. I'm just in it for the plots.
well, this makes for good viewing, right? People can see whether they were smart enough to notice how utterly fucked my analysis. You know, are you smarter than Neil Nanton, right?
Yeah, clearly I'm not.
This is ridiculous. Okay. Redo. There's much more reasonable numbers.
Okay, yeah.
This adds up, this averages out to 0. All is good in the world. Cool. These are much more reasonable numbers. And it's still incredibly sparse, so I'm taking this as a win.
Yay, sparsity. Okay. Now we have new numbers.
Why are you so unenthusiastic? This is great.
Whoa.
Lol. Wait, what?
The sign?
This is a parity neuron, I guess.
Could it be doing binary?
No way is it doing no fucking way has this model learned to do binary addition.
I don't know, man. I feel like. Okay, so it would be weird that it's making the correct sort of like unit and tens place.
Yes.
Like that would not be natural to do in binary.
Yeah, my guess is it's learned a parity second.
Oh, right. Sure. Yeah. Okay, fine. Yeah.
Also, it would be hilarious if it had learned. So I want to say for the parity neuron.
That's pretty sweet though. Like that's quite clean.
That is clean. Let me do a box plot.
It'd be so cool if you could just like fix the values to like 0.2 or whatever and see the loss go down.
Sorry?
If you just like fixed, like if you ask the model to do a bunch of parity calculations and then you fix this neuron to be the correct answer versus like the incorrect answer, see like how the loss changes or something. I think that's too high effort, but it would be cool.
I would be surprised if this neuron was like the one parity neuron.
Would or would not.
Would
Yeah.
actually I don't know. I've got an intuition, just like models are big, man. But
Yeah.
lol. It's not just doing parity.
Yeah, fuck.
Also, I do actually want to. But don't do it. Yep, good enough for me.
Cool.
Do I foresee another Twitter thread coming along? Yeah, I guess we probably want a box plot if we wanted to make like a fabulous Twitter thread from this.
Yeah. This is definitely a box plot.
Yeah, I really need to add support for box plots to Neil Plotly to make the interface less stupid. All right, where were we?
Other neurons which are duplicating all the the place analysis, and yeah. We found one interesting.
What are the other neurons, man?
Yeah, let's do it. What?
Ooh. Holy shit, if this is a mod 4 neuron. I guess mostly a sine neuron. Oh wait, I want a parity plot as well. All right, what on earth is this?
Oh, cool.
Oh,
Is it just the opposite parity?
Um, oh god, yes. This is indeed the opposite parity.
Wait, are your labels just wrong? Because it is the same as the other one.
What?
The other one is also even blue, red, odd. Oh no, yeah, they are yeah.
Okay, I want a scatter plot. So good. I did not expect looking at individual neurons to be this cute.
Having spent a lot of time looking at individual neurons, I did.
Possibly at some point I should go to bed. This is so much more fun than my actual job
Yeah.
of doing mechanistic intelligibility research.
It's also, I feel like this is like YouTube walkthroughs where it's like more fun watching someone do research than actually having to do it yourself, because like they deal with all like the low level bullshit and then you can just look at the plots.
I mean, I'm also just like, well, I don't know. A lot of this walkthrough will be Neil writes code for 10 minutes and debugs.
Yeah.
It's just teaching people a moral lesson about what
It's boring as hell.
Oh no, I find debugging therapeutic.
Okay, that makes one of us.
Sometimes it's fucking annoying and I get all the time. Especially when it's in jacks. Actually, no, PyTorch I don't know. Both kinds of are annoying.
Whoa.
I love it.
That's impressive. So it'd still be better as a box plot.
What? Come on, this is a fantastic plot. You're not taking this from me. It's so good. All right. Let's see what happens on just like an earlier thing. Still
Wait, sorry, what earlier thing? What I'm
Oh,
confused with.
I'm just looking at it on y rather than equals. Because
Yeah, sure.
hmm.
Wait, sorry, were these neurons activated on even and odd parities, or were they increase the logits of even and odd parities?
Sorry, what was that?
Are these are the parity neurons activating on even and odd numbers respectively, or are they increasing the logits of even and odd numbers?
This is a great question. So this concretely, I verified they update the logits correctly, and I did not actually check what was going on here, but equals answers built by what?
Some plotly bullshit. I can't help you.
But what? The fuck? Not all arguments.
Because those have to be cast as strings. The hover things.
Ooh.
Or sorry, yeah, the color.
Oh.
Pretty. So these only activate, right? Okay, so these correctly activate for the right thing.
Yeah.
Okay, cool.
It's majestic. All right. I want to look at
Oh, versus the
yeah.
embedding or unembedding or embedding if it's WN.
The embedding is messier.
Oh, but these should be orthogonal.
Yeah. Interesting. So these are dot products, and these are cosine sims.
Yeah.
And this is like neuron 1 in, neuron 2 in, and this is neuron 1 out, neuron 2 out. And oh no, sorry. This is neuron 2 out, this is neuron 1 out. And it's like, huh. The input and output weights are like very aligned. And the output weights are like a bit anti-aligned. Fairly anti. I was expecting them to just have like basically opposing weights. So this is kind of surprising to me.
Yeah.
Anyway, YOLO.
I mean, this is also like, yeah, what other things are these neurons besides parity neurons, right? Is like the question.
I'm sure there are a bunch.
Right, in which case, and it's probably different, yeah, a bunch, and so.
Yeah. Wait, no, actually, I'm kind of interested. So let's get some text.
That just works.
Yep. I like my utils, man. This is such a standard operation. Obviously,
Yeah.
it's useful to do this.
Also, wait, this is great because we can test if it activates on the voltage supply 105
Oh my god, I love it.
and figure 1, figure 2.
Yep. Oh yeah, I thought it's gonna be great. How long is the text? Oof. Might be a bit long, whatever. Oh man. Do I whatever. Ah. Have a utils somewhere for this. Oh no.
Oh, is this your hacky circuits viz?
Yes. And should there a reason I didn't give this my util file? Probably not. Ah. I love auto reload so much.
Mhm.
Oh
Yeah,
no, 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 no.
clearly does other stuff.
I'm admittedly mildly confused. I also don't know what the range here is. I mean, they sure are anti-correlated.
Yeah. Though they both seem kind of sparse, so just like the probability that they both activate is like pretty small.
No, that's fast.
I mean, it's what, like 1 in 10 tokens, maybe?
Yeah, whatever. Oh. Lol. Completely ridiculous. Why would my Mac think I need to go to bed at 10 past midnight?
Yeah, that's not that even. That's not even that late.
Okay, that was fun. Let's return to
Okay, so there are a bunch of other neurons that may or may not be implicated in
look at those neurons, man. This was,
what?
I want to look at
Oh no,
more
no, yeah, I think we should, no. I think this is like deeply educational is to just like look at neurons.
3, 4, 7, 8. I'm learning so much from your wisdom. I don't even have an intern that can make do this for me this time.
Whoa.
I should remove the parity neuron point. Wait, no, this is still.
Wait, what?
Fancy.
Nice.
Okay. So this is my bet is this is an ends in 7 neuron.
Hey. Yes. Yes. Wait, does that mean that there's a different neuron for ends in every single digit?
That would be phenomenal.
Ooh, wait, you could, this feels like something which you could totally just like find, right? Like take for each digit, look at whatever the weight DLA by digit minus all the others or something. Or like, yeah.
Oh my god, what? Okay, no, that's in 6, please. Well, for some reason these spike at 3 and 8. I don't know what the fuck's up with that. Oh wait, no. It's because this graph has a stupid x-axis. And really 48 is 2 times 48 plus 1, i.e. 97. Oh my god, this is amazing.
Oh yeah, because this is even odd. Wait, yeah, please, fix this at axis. This is
But the problem
no,
is
we don't care about even and odd that much.
yeah, I just have different graphs. And wait, no, I don't actually have a graph that is literally this. You make a good point.
Oh yeah, exactly.
Wait, what do I do? Oh, I zoomed in.
Oh,
Yeah, same graph.
okay, cool.
Okay, I want to get a box plot of activation against unit. Boring. Holy yeah.
Nice. And this is for units which or actual prompts which actually end in 7. This is the activation.
Yep.
Awesome. We love that.
Yeah, and this is This is also a direct logic. This is also activation based, not purely weights based.
Okay.
Still.
Oh, right, because you're multiplying by the activation,
Yeah, that's fucking
which I
let's make a fun neurons section. 7 neuron. I'm just so inspired by your French neuron and its mimetic fitness.
yeah.
13991.
Come on, I'm ready to find the 5's neuron and the 4's neuron and the 3's neuron. Yes. Yeah.
Wait a minute, this is the tens. What? That's too noisy. Yeah, no, this is nonsense.
No. No. Go back to that 10's neuron. That is oh, the median is at 0. Sorry. Yep. Okay.
Likewise here, median is at 0. And there's just not that much data.
Yeah, this is like what, only 166 prompts or something.
Ooh. Oh my god, it's a mod 3 neuron. Oh my god. If this is actually a mod 3 neuron. Oh.
Oh, but still median 0. Disappointing.
Still.
Yeah. Yeah. I'm not sure how impressed I should be.
Hmm.
Yeah.
Still, like.
Yeah. I mean, there's something there. It's just, yeah, I hesitate to call it a mod 3 neuron.
Okay.
I mean, yeah, I mean, but clearly, I mean, the whole upper quartile range is above 8, right? So that's huge. So like, maybe you just needed to go to mod 12, actually.
Sure.
Oh, that
Wow.
killed one of them.
I think it might just not have enough data.
Oh, true. Yeah. This is only 166 prompts. Yeah.
Overfitting.
Yeah, I think so.
I should stop.
No.
Yeah. Like, okay.
It's something. I mean, yeah, I just like want to see what's in the upper quartile range.
Okay, so multiple of 3, multiple of 3. Okay.
This is why I don't like doing things in Torch.
This is why you don't like what?
Doing things in Torch.
I mean, fair.
Oh, so it sure looks like it doesn't like anything in mod 3. Or oh, so it's when everything
Yeah.
it's when everything's mod 3? Or 0 mod 3?
Looks like it.
Whoa, no, yeah, wait, this is super clean.
Yeah.
Oh.
I feel like I felt to get excited because I'm in running code mode, even though I'm basically just fully convinced this will work. God damn. Wait, what? Oh.
Wow. So what the fuck? So what does this imply about the addition?
Sorry?
What does this imply about the addition circuit? It's like
Uh,
doing some like fucked up number theory tricks.
uh, honestly, my hypothesis is it's just a stacking an enormous package
Yeah.
Oh my god, if this is doing some Chinese remainder theorem bullshit, I'm gonna quit it. Oh, this is so good.
Hold on. What? Okay. Yeah, okay. I assume you know more number theory than I do.
This is probably true. Relics of a misspent youth.
Look at you now. Finding mod 3 neurons. How far we've come.
Insane. I
Oh
did
my
a big
god.
blog post called the neurons.
Yeah.
Though, I mean, really, if you wanted to do this properly, you'd want to like get a bunch of prompts. And that sounds like so much effort. But like, who can be bothered?
One of my undergrads could maybe be bothered.
Are you offering?
I mean, it depends if they want to. Like, I'm not gonna force them to. But if this is like, I'm also having them do like research sprints and stuff this after next week. So
Like you're running your own maths program.
I am.
What?
I literally have a Slack channel called Maths Light.
Ah! Ooh, it's another parity neuron.
Ooh.
I bet. Ah,
Why are there so many parity neurons?
sure.
So why would there be so many parity neurons? I guess 3 isn't that many.
Parity is important, man.
Um,
Cool. It's a parity neuron.
cool, yeah.
Oh man, which one was the 7-year-old? Whatever. 7-year-old has lost to us forever. Be this one. Oh wait, no, that's the parity. What was the 7-year?
I still feel like, yeah, there's something to do here of just like looking for programmatically looking for the neurons which have the highest single token peak versus all others.
What exactly do you mean by that?
So like, actually wait, go back to the, well, yeah. Like wherever that one plot for the 7 neuron where like the 7 just like really sticks out over all the others.
Yep.
Yeah, like presumably we should just be able to like construct this plot for all neurons and like find the ones which are spiky.
Yep. Sure seems easy to do. Oh my god.
And this should yield
This is
like,
a mod 4 neuron. I think this might be a mod 4 neuron.
yes.
Oh no, it looks like a parity neuron.
Oh, boring.
Boring. Yeah.
This is a pretty big activation range though. For like the, yeah, even within the correct parities, there's like a pretty big range here.
This is true.
Though, yeah, again, I think this is probably too small of a data set.
Yeah, 18 neuron. Oh. Boring.
Only parity.
Yeah. Actually, wait a minute. This neuron was like not just parity.
Oh yeah. Very unembedded.
It also. Hmm. I'm just going to pre-commit to the number of plots I'm allowed to make. Oh,
Boring.
I know. Okay, let's repeat this analysis.
For all of them.
Nah, no obvious pattern. Yeah, no, I got nothing.
Oh wait, are they all? It looks like each. Oh no, wait, this is just a number theory fact. Never mind.
Were you observing the? There's
Yeah, yeah.
This is indeed a true number theory fact. But why does it have mod? Annoyed. All right, two more neurons, then we move on.
Okay. I feel like you picked all the.
I want to do first layer 17 neuron. Oh, looks like a parity neuron
What the? Hmm.
with a bit of like 3 and 4 stuff. Wait. Oh, lol, I'm just plotting the Fourier basis. I was like, that's structured. I'm gonna call this a mediocre parity neuron.
Yeah.
Though this is interesting. Does this happen? All right, final neuron. This one. Ooh, that's original. What? Is this a mod 5 neuron? Like, predict is gonna have spikes at like cos and sine 80.
Hmm.
Ah! Oh my god. This is a mod 5 neuron. This is fucking incredible.
Yeah, I feel like we should. Yeah, it would definitely. It seems definitely possible to just enumerate all of the. Yeah, all the neurons which are like mod something.
I agree. I'm just like her not to do it.
Yeah, no, that's fine.
One or two mod 5 here. It's so great.
Yeah.
All right, I'm done. Let's
Yeah.
returns.
Victory. We now understand addition.
Sorry?
Nothing. Oh, we're doing tens now. Cool.
Yeah, of course. I'm not gonna give up that easily. Ooh.
Yes.
Ooh.
Wait, is that? I feel like we saw that neuron before.
Oh,
Maybe
no.
it was like in one of our erroneous calculations. Yeah.
Possibly. This could be the always on neuron. I have a bug again.
Yeah, I think it might be.
Oh,
Oh,
That sure looks like a mod 3 neuron. Is that the mod 3 neuron? Oh, it was the Oh, because it's a mod 3 neuron and 3 is not a divisor of 10. This also matters for the tens digit.
Oh,
It's fucking incredible.
wow. Okay.
I love it. Back to the drawing board. Okay. That's a smiley face. That's what? What?
Oh. Whoa.
What? So it's got a significant like mod 100 thing.
Yeah.
The beautifully named 80-20 mod 100 for the tens digit neuron.
That'll get a lot of Twitter traction.
I am the master of writing great Twitter threads.
Yeah.
It'll be great. 12978. Oh. That sure looks like a mod 3 neuron. Hmm. It really doesn't. It doesn't want to be not. It doesn't want to be a multiple of 3.
Oh, yeah, wait, scroll up. Yeah, okay, fair.
Oh, I'll take that as a win.
Mhm.
I'm so great at naming things.
You still have the N capital though. Is it a capital neuron?
Yes.
The proper neuron.
That's majestic.
Yeah, so addition is just going to be like really cursed, right? It's just going to be this like huge pile of heuristics.
Uh, I don't quite want to give up yet.
I guess, yeah. I mean, these things are pretty sparse still, so I feel like there could be like algorithmically, I don't know, we have a bunch of these like, yeah, mod whatever neurons.
Yes. Oh, I just put a next neuron by accident. Cool. All right. My prediction is that all of these ones are significant mod 10 neurons.
Okay.
Wait,
What all are?
sorry. My prediction is that all of the neurons that are important for predicting the tens digit are actually mod 10 neuron. Are actually mod 3 neurons.
Oh. So you're saying it's using mod 3 neurons to do the like tens place prediction.
Yes.
Okay, cool.
That is my prediction. I guess we can quantitatively test it.
As in
Well,
by ablation?
I was thinking we just literally take this term
Oh.
because it works, man. Okay. I should really create a neuron data frame and then add scores for a bunch of stuff.
Mm-hmm.
Tens affecting score. This is interesting enough to actually get a cell. This is reaching. We're doing it in a notebook might make more sense. But also maybe as Kota often decides notebooks should be extremely slow for some reason. It's part of why I don't use them.
Wait, in like whatever in this cloud provider?
I don't know if it's a my end bug or a cloud provider bug.
Oh,
I mean, also partially just notebooks get slow when you have a billion plotly plots in them.
sure.
I don't know if it also happens with matplotlib.
It doesn't.
Do you say it doesn't?
Yeah, it does not.
Because they're so useless that the notebooks.
They're just so lightweight.
Ah!
I think it's the word you're looking for.
Yeah, useless. What? What? It does not have a type. That's the thing.
Mm. Ooh. Oh, cool. Talk about heavy tails.
Yep. I don't actually have great visual intuition for this, admittedly. I'm like,
These are the neurons. These are like mod 3 neurons, right?
sorry?
These are mod 3 neurons, which you're plotting.
Yes.
The extent to which they are mod 3-ish.
Yes.
As measured by how much they compose with things mod 3 in the unembed.
Yes.
Okay.
I don't
Oh, cool.
think the sign here has much meaning.
Does or does not?
Does not.
Wait, aren't the negative ones the ones that like are this but not remainder 3? Like that other one that it was like not mod, like not 0 mod 3 or something like this?
Yeah, that sounds plausible. I guess it would be something which boosts a specific thing mod 3, I think would be positive here. Something which suppresses a specific thing would be negative. And
Oh,
something
but in some sense, it's still a mod 3 neuron. Okay, yeah.
I don't really know. I could easily have those all the way around, or it could just be boring.
Sure. Yeah.
I love rug plots, even if they melt my notebook.
Yeah, the rug plots are nice.
It's almost like a library from the 21st century. It's useful. Okay. Cool. These are the two interesting neurons.
Nice.
That was pretty worthwhile.
Yeah.
6901. That's a smiley face. And 24,001.
Ooh.
Oh no, this is the thing of like, it matters mod 100.
So there's another smiley face.
It's like a shifted smiley face.
Mm.
It's also like pretty damn periodic. Such that
Yeah.
it has a big spike at cos 4.
Hey. Oh, sign for
The same thing.
close enough. Yeah.
It's majestic. Okay. This is a rabbit hole.
Yeah.
I should go to bed. What are natural next steps for this project?
Bigger data set where you can, just like, yeah. I mean, because you can make a pretty big data set just by taking literally all pairs of numbers. I think all of this analysis, just like making it more programmatic. But like there were a bunch of things which you did, which you could just like programmatically do for all of the neurons. And then subset the interesting ones. What is this calculation? Oh,
This was how many megabytes would the neural activations for every single pair of added numbers take up.
and that's not bad.
Yeah, it's pretty chill actually. Expecting it to be much worse.
Wait a minute. You're missing times layer.
That's the 5.
Oh.
There's only 5 relevant layers in my opinion.
Oh, okay. I thought you were only doing, okay, I thought the 5 was the other tokens. Yeah, okay. Yeah.
Oh, there's also the 2-shotness, but that probably doesn't matter.
Yeah, I don't think that matters. This is like learning how to do addition in context.
That's GPT-5 level galaxy brains.
Yeah, it's the kind of bullshit though I expect these models to do. I guess you could test that maybe with like the 1-shot performance versus like the 10-shot performance. If it like actually meaningfully gets better or something.
Yes. Okay. What? So I guess to me, So I feel like to me the like thing that feels sexy is like sorry. The thing which feels like it would be sexy is like having having some story for what the actual algorithm is. And even if I don't know how it's like fully mechanistically implemented in the neurons, just being like, yep, this is like roughly how this works. And let's see. Oh, here's a stupid idea. I can just look at
Hmm.
$21 and $693. Direct neuron attribution. Oh. That's interesting. Oh, wait, sorry. Okay, let's take the parity neuron and weird. So I'm basically trying to figure out, like, to what degree is there meaningful composition between the neurons versus it all being a mess?
Mm-hmm. And this is like anti-composition. Though, again, I think the point always still stand that it's like mostly useless to look at MLPs aggregated like this.
Yeah, I mean, so. Okay, let's do this differently. So
Mm-hmm.
ooh. Wow.
Okay, that's cool.
Okay. Let's go and look at the neurons in layer 16.
Mm-hmm.
So no, I do not. But oh, um, what? What? Oh,
Hmm.
this now makes more sense. Ooh. That is exceptionally sparse.
Mm-hmm.
Jesus. I don't actually know if that solves the problem.
Wow. Wow.
Uh, yes, I was not expecting this to be. Okay, okay. So source. Man, what am I trying to do?
Um, you can see, yeah, I guess when they activate, you can see their direct logit attribution.
Oh yeah, I mean, I may as well feed these into the thing above.
Yeah.
Which now I think about it, I really should have just made a function.
Yeah.
This is rather the point of functions.
Yeah.
But you know, that's less fun.
Yeah, let's just like see how long we can make the notebook. Whoa.
And there I will prepare to label this like lol.
Hmm. Wait, and this is like a proto-parity neuron? Yeah, I guess it kind of looks like it, yeah.
Yep. It sure looks like a proto-parity neuron.
So wait, is it just like a shitty parity neuron?
Looks like it.
Or maybe is there something like mod 4 here where like, or like, yeah, like what explain, like the median of those boxes are pretty high.
Yeah, I'm just modeling this as like a really noisy parity neuron.
Huh.
Let me. I liked the thing where I just iterated through and printed a bunch of stuff. I can't see what that is. Ah, there it is. No obvious pattern.
Yeah, I mean, it just seems to like threes and ones. I think I'm actually more interested in the pattern on the low end, right? Because it was the medians of the off bins, which were always high.
Yeah.
Oh, well, no, there are a couple of zeros in here now. The zeros always look like two. No, no, there's a 0, 0, 0. And then there's also a bunch of 2, 2 zeros.
Yeah.
0. Yeah, I don't know. I don't really see anything here. This looks pretty noisy to me.
Yeah. Let's step one level back.
Just progressively noisier and noisier parity. It's like a diffusion model. It's like pure noise, and it slowly denoises the parity bit.
Checks out, man.
Honestly, I feel like based on like residual stream being or ensemble of shallow paths and like all this stuff. Let me check out. Ugh.
Oh. Sure seems like progressive.
Diffusion addition.
Oh man. Yeah. All right, I'm definitely gonna call it a night here.
Yeah.
No. Man, all right. Let's suppose I was handing this project off to an intern. What would I say? Something like, sure seem to be a bunch of neurons that are doing something.
Yeah, I would just like make a big ass data frame where you have all of your numbers, your like X's and your Y's, a bunch of properties about those, and a bunch of interesting neurons, and then just like make a shit ton of plots and like see what falls out. This is how this would be my next step.
Yeah, I guess one question I'm pretty curious about is like, I'm gonna find a mod 7. it will bring me so much joy if there is a mod 7 neuron hiding out there. Yeah, I just have this conviction there should be like a real addition algorithm here, not just a stack of heuristics. And maybe this is just false. Anyway, in that vein, things that draws me towards are like, can we restrict things? Can we do path patching to show whether MLP layers compose with each other? Can we look?
Doing path patching on pairs of neurons sounds hard. Or I guess if you're
Oh.
restricting them to the, sorry.
Pairs of MLP layers.
Oh, I'm less excited about that.
Because you just think it's going to be like a bunch of different subcircuits, and this is
Yeah, exactly. Yeah.
yeah, fair.
There's literally 16,000 neurons per layer. You're just averaging over that. Like, I mean, we see it here, right? Like, it's clearly pretty sparse.
Hmm.
In a way where like you could just like take a subset of like the most interesting neurons and then do path patching on like those.
Yeah. Yeah, this is interesting. I vaguely hypothesize there's some kind of a like. Yeah, I mean, one question that does feel exciting to me is how much it's like actually the case that you can recover good performance with a small number of neurons.
Mm-hmm. Yeah, I'm not sure if that will actually work. I would feel more confident that you could like heavily degrade performance by ablating a few neurons.
Oh, interesting. I totally have a I have an intuition that the degrading performance would be harder because something backup behavior. But no, I think you're right. This thing is sufficiently distributed that getting sufficient. Well, I kind of just also have the model that like there's going to be a bunch of redundancy. Deleting any one bit doesn't make an enormous difference, while patching in the one bit can make a big difference.
My model is that like it's just easier to break things in general, right? Just in all things in life, not just models.
Models are smart, man.
Yeah.
I got your number.
Yeah.
Anyway, all right.
Okay.
Let's call it a day here. But you know, if anyone watching this is interested in building on it, my code will be in the video description.